Okay, so this video is going to be about the derivatives of trigonometric functions. So, yep, there goes, functions. All right, so we're talking about sine, cosine, tangent, cosecant, secant, and cotangent. All right, so there are 6 of these. They're things that are probably best if you actually put them on flashcards or Quizlet or something like that, because you're going to need to know them and you're going to be able to recall them kind of quickly. All right, so what I'm going to do is I'm going to go through the list, but I'm going to stop at a couple of points just to kind of see, so you can see where these things come from. The derivative of the sine function is actually pretty straightforward. It's just the cosine function, unbelievably. And what I'm going to do is I'm actually going to prove this, okay? Because it takes a little bit to think this through. In order to prove this one, we need a little bit of a fact from trigonometry, okay? We need to know that if I have the sine of alpha plus beta, this is sine alpha cosine beta plus cosine alpha sine beta. Okay, so that you can go double check with me on this, but that's an old trig identity that hopefully you've seen somewhere before. Sine alpha plus beta is sine cosine plus cosine sine. We'll see. Hopefully you have some memory of that. If not, go back and check through trigonometry stuff. All right, so let's prove this. So we actually go to the definition here, right? The definition. So the derivative of the sine of x should be the limit as h approaches 0, right, of sine of x plus h minus sine x over h. So that's what the definition of the derivative tells me, right? So note, if I apply this trig identity, I get an interesting result, right? I get that this is equal to the limit as h approaches 0. So it's sine x cosine h, right? Plus cosine x sine h minus sine x all over h. Okay, so that's interesting. Let's see, that just made a big mess. But if I do a little bit of rearranging, okay, I can rewrite this as 2 separate limits. Okay, so I'm going to take this piece here and this piece here and bring them together. Limit as h approaches 0 of sine x times, let's see, what do we got here? Cosine h minus 1 all over h. So that's the sine x times cosine h gives me this. Sine x times 1 gives me that, so I've dealt with that. So what's left? I have cosine x times sine h over h. And I'm taking the limit of all of this, right? All right, so note, h is going to 0. All right, so this is sine x times this, the cosine of h minus 1 over h. Aha, but I know something here. That limit is 0. Cosine minus 1 over h is 0. And the x, this is an x, so that's not moving as h is moving. So this is sine of x times 0. And then if I take the limit as h is approaching 0 here, this is sine of h over h. So that's the other one that we have memorized. That's 1. So that's cosine of x times 1. And lo and behold, that goes to 0, leaves me with cosine x. So this is why this works, okay? So you need this little trig identity to make that work. Now, for the BSc exam, you don't need to know how to do this. I'm just trying to give you the idea that these things aren't like coming out poof magic from nowhere, right? So, all right, the cosine proof is very similar to this, but we're just going to state the cosine one, and we'll move on from there. So we just said that the derivative with respect to x of the sine of x is the cosine of x, and we proved that. And number two, the derivative with respect to x of the cosine of x is very similar. You gotta be careful here though, it's the negative sine of x. So sine goes to cosine, cosine goes back to negative sine. Now you can do some research here and you're gonna find that this works pretty much because of a similar trig identity. And you could prove that yourself. I'll leave that to you. The tangent, though, is one that we can derive much easier. So the derivative of the tangent is actually the secant squared of x. That seems a little odd. Let's prove that. Okay, so proving here isn't so bad, because this is the derivative with respect to x of the tangent of x, which means tangent of x, which is the same as the derivative with respect to x of sine x over cosine x, which means that I can use the quotient rule, right? Which is low d high minus high d low. So the d low here is negative sine x over low squared, right? So cosine squared of x. So let's rewrite that here with using squares here, right? Cosine times cosine is cosine squared x. Minus and a minus is going to make that a plus sine squared x over cosine squared x. And lo and behold, this by trig identity is equal to 1 over the cosine squared of x, which is, well, 1 over the cosine squared of x is the secant squared of x. So that's the tangent, right? So proving the cotangent works very similarly. Likewise, also proving the ones for cosecant and secant, you can actually do those also using the quotient rule. So, all right, let's kind of keep going here a bit. Okay, so at this point we have three derivatives for trig. The derivative of the sine of x is the cosine of x. The derivative of the cosine of x is the negative sine of x. Number three, the derivative of the tangent of x is the secant squared of x. So we've seen that one proved. Not too bad. And then we have the other three trig functions. So, and you can prove each of these using the quotient rule, just like we did with the tangent. So if I have the cosecant of x, this actually becomes the negative cosecant of x times the cotangent of x. Okay, that's a tough one to memorize, but it doesn't come up frequently. These last three do not come up frequently on the exam. If they do, and you know them, wonderful. If you don't, you may want to be able to derive them at least. If I take the derivative of the secant, it is the secant of x times the tangent of x. Now, again, this one comes up not as frequent as the first three, but if there's one of these less frequent ones that comes up more often, it's this one. Okay, so the secant is the secant tangent. It likes to pop up sometimes. The last one is the cotangent. So this is the cotangent of x. And in this case, well, it's very similar to the tangent. It's just the negative cosecant squared of x. So just like cosine is negative sine, where tangent is secant squared, the cotangent is the negative cosecant squared. Again, not happening very frequently. If I had to memorize only one of these three, I would memorize this one. However, it is helpful to know all three. But of all of the things that you have to memorize, these are three that I would like hold off on. But, there you go. All right, so these are the trig functions.